Hello, students. I am Dr. A. Bhuvaneshwari, Assistant Professor from School of Computing Science, VIT, Chennai. Today we are going to see about redundant array of independent disk, which is shortly called as RAID. The topics to be covered for today's session is the introduction about RAID, the requirement or the need for RAID, and the types and levels of RAID, and then how well you can select a RAID based on the requirement and the input output performance and the references. So, what is actually a RAID? RAID is abbreviated for redundant array of independent disk. It is actually a simple technology which is required to associate various secondary storage devices and in order to utilize a single storage media. So, why we are going for this RAID is the reason why is the single large expensive drive, because a simple hard disk which is available inside your computer will leads to a very less performance, whereas if you are going to chain multiple expensible disk, for example a hard disk, into an array of disk drives, which will enhance the performance. So in what aspect this RAID is going to enhance the performance is, for example, if your computer is going to have a hard disk which is a single SLED hard disk. Okay, so what happens if your computer crashes? What happens if the hard disk drive is down? You can't get back the data which is available inside your laptop where the hard disk is available. So, for that reason, what we are going to do is we are going to have an array of disk drives which is going to act as a secondary level of storage device, which will associate in multiple orders in order to provide the fault tolerance of the given data which is available inside your data disk. It will improve the performance when comparing with the single logical storage. So why we are going for the secondary storage device? The reason why is we are going to have a fault tolerant device. At any cost, your data should not be lost. And also, the virtual memory is going to play a major role in a primary device, and it is going to be act as a magnetic structure, and it will be having a moving head disk mechanism in order to read and write. So we are going for a secondary storage device. So what is the use of you having a RAID is it exploit collection of disk where it includes some mechanisms like stripping, mirroring, parity, and it will be inexpensive disk in basic. It will enhance the speed, improve reliability, and it will combine both the speed and reliability on single stand. And also, it will going to collect single disk of the system. So, what happens when your data is lost? See here, often you need your data to get have a backup of our data. What is actually a backup? Instead of having a single copy of your actual data, you're going to store it in another device which is going to be the backup of your data. So often you will be having the habit of taking the backup of your actual data, which may be a daily basis, weekly basis, or a monthly basis. So you have to ensure which type of data is actually a device where your data is taken as a backup, and also how long the time it takes to recover from your data. For example, if suddenly due to some disasters, okay, your entire server and its data center has been collapsed. So at that time, how you will recover the data? So for they have given a simple example which will explain you how well this multiple disk drives is going to be. So your system is going to have nearly about 100 disk. Okay, the system is going to have a system is going to have a 100 disk. Okay, and the mean time to failure is going to be 100,000 hours, so it is going to approximately 11 years. So you have to make use of the system, whereas the mean time to failure is 1000 hours, that is approximately 41 days it will take to uh, leads to a risk of failure. So the usage of this multiple disk failures will leads to the increase of the risk of failure. So at that time, what you can do is you have to improve the reliability. So how I can improve the reliability? The big problem with this in the case of the uh, SLED reliability is very big problem because it is depending upon one single hard disk. So if the data is lost, the entire data is gone. So in order to avoid this problem, the probability of the failure across the multiple disk drives is going to get increased so that it is directly proportional to the reliability. The redundancy is going to be directly proportional to the reliability. So in that cases, if you're going to have 100,000 hours, whereas you're going to have certain number of n number of disks, so the probability is going to be 41.66 days. So in this case, how we are going to avoid such probability of failure? The only solution is redundancy. Okay, so how you can actually achieve this redundancy problem? Okay, so the one major usage of redundancy is way of achieving this redundancy is mirroring. Okay, so you're going to do the mirroring of your entire given hard disk. So you're going to have a database. Okay, so you're going to have a mirror of the same database in somewhere, not in the same location or in the same cloud. So you can have it in in some other location also. Okay, so if there is one know the disk failures, the data lost can be read from the other disk. It is like a backup. If you are going to lose your data in one single device, it will be retrieved from other disk. This and also the second disk also, if it fails, the first disk will be replaced before the data has been completely lost. So in this way, you're going to have the RAID level. Then data mirroring and then data stripping. So data stripping is going to be some intensive environment where the transfer rate is going to be hypothetical. Okay, so how this transferring rate is going to be in intensive environment? Okay, so at that stages you can make use of some highly multitasking environment based on two levels of stripping. One is bit level stripping, another is block level stripping. So when the request has been raised in parallel, you can go with this bit level and block level stripping. The greater the request of the strip size is distributed across the multiple requests is directed to multiple disks where the data stripping has been available. So we'll see one by one. These are all the levels of RAID. So the first level of RAID is RAID level 0. RAID level 0 is very simple. RAID level 0 is carried out by making use of the concept called as stripping. Okay, so how data stripping has been happened? Okay, when you are stripping the data, it is going to get increased data throughput. Okay, so it is going to be like, I'm going to strip the data, I'm going to strip it as first block in the first disk, second block in the next step, third block in the next step, fourth in another disk, fifth in another disk, 16. So in some order, it can be a round robin scheduling, or it can be a first come first serve scheduling, or any order of scheduling. Okay, in some way, the data is going to get stripped across various disks. Okay, this is RAID level 0. The next thing is RAID level 1. So RAID level 1 is going to be like, we're going to have a concept called as mirroring. So what is this mirroring is going to do is, it provides a redundancy through the mirroring where no data is lost, because the same data block will be available in this block also. If this particular, if for example, if this particular uh, disk has been failed. So what happens? The data of 1 and 3 can be retrieved from this particular device. So this is called from this disk, that is called as level RAID level 1. Okay. So the next level is going. This is another example. So they are going to strip it as 0, 1, 2, 3, 4, 5, 6. So like this, you can make use of. Otherwise, you can do the mirroring, the same concept of 0, and it can be stored in another level. In the same model, you can do the stripping. In RAID level 2, we're going to see about we're going to have the error correcting code. So why we're going to be anticipated about this error correcting code is, If one of the fails, okay, from its actual disk location, using this error correcting code, we are going to rebuild the lost data. The reason why we are going for this redundancy error correcting code is it is for mainly for data security. For data security, you're going to do this and you're going to reconstruct the image. In RAID level 3, we're going to have the concept of bit interleaved parity. So it is going to calculate based on the parity disk. So each and every device will be having its own sector where the bit interleaved parity will be available. See here in this last disk, the parity bit interleaved parity is available. So it is um it is going to be the storage overhead is almost reduced because only one parity disk. You may ask me a question like why we are going to store this parity. This is also an extra storage which is going to consume some space, but still this parity bit interleaved parity will be able to rebuild the data whenever there is a data is lost. Okay, now we are going to see about RAID level 4 is going to be block interleaved parity. So what is this block interleaved parity is? The strips are going to be in the zero. In certain documents, you can separate disk which will have the block interleaved parities will be available for each block. There will be a block interleaved. But in the previous case, we have bit level for in